Bismillahirrahmanirrahim. Assalamu alaikum students. This is Hamza Noor, and in this video I'm going to solve question number 6 of International A-Level Edexcel M1 Mechanics January 2022 paper. And this question is based on the topic vectors. So here it says that a particle P of mass 2 kg moves under the action of two forces, Pi plus Qj Newton and 2qi plus pj Newton, where p and q are constants. And here we have the acceleration of the particle, which is I minus j meter per second square. So the requirement of part A is to find the value of p and the value of q. So here we are going to apply the Newton's second law of motion. Here we have two forces. One force is pi plus qj, and the other force is 2qi plus pj. Okay, so we are going to say that the sum of the forces is equals to mass times acceleration. So we are going to say this is force 1 and this one is force 2. So sum of these two forces will be equals to mass times acceleration. So F1 plus F2 will be equals to mass times acceleration. So therefore we can say that Pi plus Qj plus 2Qi plus Pj is equals to mass times acceleration. The mass of the particle is 2 and the acceleration vector is given to us I minus j. Okay, so we are going to solve this equation. We are going to compare the coefficients of I and the coefficients of j in order to find the values of p and q. So what I'm going to do is that I'm going to separate the terms of I and the terms in j. So we can say that pi plus 2qi plus qj plus pj is equals to 2i minus 2j. So we are just going to compare the coefficients of I and j respectively. So therefore we can say that taking I as common multiplied by p plus 2q plus taking j as common multiplied by q plus p. And this whole thing will be equals to 2i minus 2j. So now when we compare the coefficients of I and j, we can say that p plus 2q is equals to 2. This is equation number 1. And then q plus p is equals to minus 2. This is equation number 2. All right. And if I make p the subject in equation number 2, so therefore p is equals to minus 2 minus q. And I'm going to substitute this into equation number 1. So minus 2 minus q plus 2q is equals to 2. So therefore we can say that q is equals to 2 plus 2. The value of q is 4. And then we will find the value of p. P is equals to minus 2 minus 4. Therefore p is equals to minus 6. So here we have the answer of part A. P is equals to minus 6 and q is equals to 4. All right, then we have part B. It says that find the size of the angle between the direction of the acceleration and the vector j. All right, so I'm going to erase the working of part A from here, and I'll just mention the answers of part A. P is equals to minus 6, Q is equals to 4, and I'm going to erase this part A working now. So what we need to do, we need to find the size of the angle between the direction of the acceleration and the vector j. Since we know that the acceleration vector is I minus j meter per second square. So if we mark this vector over here, as we know that acceleration is equals to I minus j. So this means that horizontally you are going 1 unit towards right, and vertically you are going 1 unit downwards. This will be the vector, basically the acceleration vector, and this point is basically the origin. So we need to find actually this angle, this complete angle. Okay, so as we know that this angle is 90 degrees. So if we just find this angle theta, okay, so if you want to just find this angle theta, you will consider this triangle. So you are going to say that tan theta is equals to opposite over adjacent, which means that tan theta is equals to 1 over 1. So therefore theta is equals to tan inverse 1. All right, so theta will be equals to 45 degrees. And then what we are going to do, we are going to add the angle 90 degree into theta. So therefore the required angle would be 45 plus 90 degrees. So therefore your answer to part B is 135 degrees. As simple as that. So now we have some information before part C. It says that at time t is equal to 0, the velocity of p is 3I minus 4j meter per second. So this is basically the initial velocity vector. It is the vector of u. And then it says that at time t is equals to capital T seconds, particle p is moving in the direction of the vector 11I minus 13j. So requirement of part C is to find the value of t, where t is capital, t is an uppercase letter. So according to the information which is given to us so far, what we know the fact is that when time t is equal to 0, we have a velocity vector of 3I minus 4j meter per second. So therefore we can say that the initial velocity vector u is 3I minus 4j meter per second. Okay. And we also know that the acceleration vector is I minus j meter per second square. And since we know the fact that when t is equals to capital T, when the time is capital T, the particle is moving in the direction of the vector 11I minus 13j. So what we are going to say is that the velocity is a scalar multiple of this vector. Since the particle is moving in the direction of 11I minus 13j, so we are going to say that v is equals to k times 11I minus 13j. Since the particle is moving in the direction of the vector 11I minus 13j, so obviously this is a case where we say that one vector is a scalar multiple of another. So we are going to say that the velocity is equals to k times 11I minus 13j, where k is a constant. So as we want to find the value of t, we are going to use this equation of motion. V is equals to u plus at, and the final velocity vector is k times 11I minus 13j, and it is equals to u plus at. The initial velocity vector is 3I minus 4j. Okay. The acceleration vector is I minus j, and time t is capital T. All right. So we are going to say that 11ki minus 13kj is equals to 3I minus 4j plus ti minus tj. So what we are going to do, we are going to compare the coefficients of I and coefficients of j. So 11ki minus 13kj is equals to, taking I as common, multiplied by 3 plus t, taking j as common, multiplied by minus 4 minus t. So the I component will be equated with the I component, and j component will be equated with the j component. So I'm going to erase the working of part B from the top so I can make some space. All right. So 3 plus t will be equals to 11k, and then minus 4 minus t is equals to minus 13k. So we are going to make k the subject in both of these equations. So k is equals to 3 plus t completely divided by 11, and k is equals to minus 4 minus t completely divided by minus 13. And then I can do another step over here, which is k is equals to taking minus sign as common, multiply by 4 plus t, and it is divided by minus 13. So therefore k is equals to 4 plus t completely over 13. So we are going to equate k with k. So therefore 3 plus t completely over 11 is equals to 4 plus t completely over 13. So 13 multiplied by 3 plus t is equals to 11 times 4 plus t. So 13 times 3 is 39. So 39 plus 13t is equals to 44 plus 11t. Therefore 13t minus 11t is equals to 44 minus 39. So therefore 2t is equals to 5, and therefore t is equals to 5 over 2. T is equals to 2.5 seconds. So here we have the answer of part C. T is equals to 2.5 seconds. So this was basically the question number 6 of International A-Level Edexcel M1 January 2022 paper.